For all the talking I've done about audio in GameMaker recently, you knew it was just a matter of time until I brought it into 3D. Hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and let's talk about 3D sound. So far in our adventures in sound in GameMaker, all of the sounds that we've been playing have not been, as they call it, diegetic. They have not emanated from any particular point in the world. They've just played at their original volume. And it doesn't matter how far away from you the object that is associated with the sound is, it will play at the same volume as a sound that is associated with an object that's standing right in front of you. Let's change that. So a few things before I start. I'm going to be using 3D for this demo, but this also is something that you can use for 2D games. Positional sound can be quite useful for 2D games. The only real difference that I can think of for doing this in a 2D game that you'd want to consider is that you would basically just assume all Z coordinates are 0 when it comes to positions. Two, I've said a few times in the past that positional sound often gives me headaches. Usually because if I hear sound coming out of like one of my headphones and not the other, I'll assume that there's either something wrong with my headphones or something wrong with one of my ears, and I don't like that. And I'm pretty sure that's just a me thing, but if you have similar experiences, just a small warning, there's going to be a lot of positional sound in this video. And not only that, but I'm kind of going to be exaggerating it on purpose because I think that will make it easier to demonstrate what's going on. So if that's something that you might not really like, consider this a content warning of sorts. Might be worth just skipping this video. So, like I said, I'm going to be playing a little bit with positional sound in my my 3D demo scene. And you could go wild with this. You could have every sound in your game play. You could have every sound in your game emanate from some position in the game world. But I'm just going to be making use of this here accordion music. Right? That little 30-second loop, and I'm going to play it from different positions in the world, and I'm going to do different things to it, and hopefully that'll be enough to get across what you can do with positional audio and how you would write the code to deal with it. So when you add your sounds that you want to play at a position to GameMaker, you're going to want to do just a little bit of setup to them to enable them to play in like positional 3D space. You're going to want to look at the output type for the sound, and you're going to want to make sure that either mono or 3D is selected. These two options are actually the same option. GameMaker just makes the executive decision to like allow you to select an option that says 3D just because that is perhaps a better indication as to what you're going to be doing with that sound. But ultimately, the sound just needs to have a single audio channel. If you have stereo sound with two audio channels, then it will just play out of your left or right speaker, depending on what the depending on the volume of the stereo tracks.
Hey.
You should still be able to have the sound's volume attenuate at a distance. It just won't be positional. So I'm going to set this back to mono, and we can be on our way. So there is a, I guess we can call it an easy way and a hard way, or at least a more advanced way of doing positional sound in GameMaker. In either case, the first thing you're going to want to do is use the function that is audio falloff. Come on, audio falloff set model. And this is going to set the audio falloff model, which will determine how exactly the sound does attenuate at a distance. If you type audio falloff, you can see a list of different audio falloff models. There's audio falloff inverse distance, exponent distance clamped, exponent distance. Audio falloff none is, I believe, the default setting, so with this, the sound will not attenuate at a distance. This is fine for things like UI sound effects, or other, as they call it, non-diegetic sources of audio, like background music. But if you want to have, for example, an explosion, and if you want to make the explosion make a sound, and you want the explosion's like volume to be lower if you're farther away from it, then you're going to want to select one of the other falloff models. And you can play around with these as you wish. I'm going to go with audio falloff inverse distance. This should be sufficient in most cases. And if you hover over the macro in GameMaker with feather enabled, you can actually see the calculation for how the final volume is calculated with the different audio settings. You can also open it in the manual, and you can see a description of the equations that each of the falloff models use, and also some diagrams, because everyone likes diagrams. but I'm just going to set that to audio falloff inverse distance for now. The next thing I'm going to want to do is use a function that is audio play sound on. No, audio play sound at. There's so many audio play sound functions, it's annoying. We're going to use audio play sound at, and this is going to be pretty much the same as the regular audio play sound function, but it's going to take some positional arguments. So first we have the sound ID, which in my case can just be that little bit of background music. We're also going to have an X, Y, and Z position. I did say that I was going to have the sound emanate from the pirate ship, so I'm going to make that 250, 250, and 40 as our 3D coordinate. And that's roughly where the pirate ship is. Our falloff reference distance is going to be the distance away from the source of the audio at which the volume is half of its maximum volume. I'm going to make that something like, say, 200. We're going to have our falloff max distance, and this is the distance after which the volume will not attenuate. This will just be our minimum. After this distance, the volume will be at its minimum. It could be 0 or it could be some other minimum. I'm going to make that, let's say, 2000. Our falloff factor is going to be an additional parameter in the curve of the audio falloff model, essentially affecting how sharply it cuts off. And after that, we just have our regular audio parameters. So loops can be true because this is music. Priority can be 100, just an arbitrary value, which is going to be relative to the other sounds. Priorities, I've gone over that in the past. I don't feel the need to explain it again. Next, there's one more thing we need to do before we can have positional sound, and that is going to be to set the position of the emitter. So in pretty much all cases, that's going to be the position of your camera, whether that's a camera in 3D space or a camera in 2D space. Again, if you're doing that, just set all these Z coordinates to 0. And we can do that with the audio listener position function. And the audio listener's position can essentially just be the camera's X from, Y from, Z from. As I said, there's not that much to it. You just have to make sure that the position of the audio listener is positioned appropriately relative to like where you're actually viewing from in the game. So if I run this now, we're going to hear some things. So if I get right up close to the pirate ship, we can hear the music at roughly maximum volume. And if I get far enough away, the sound starts to fade out. I don't know why I closed the game, I'm not done yet. So, positional audio. So I'm going to stand in front of the pirate ship, and I'm going to move to the left and the right, and I'm going to ask you to listen carefully to where the sound is coming from, and to figure out if something seems a little bit off about it. So if I move this way, and if I come back, and if I go the other way, I'm gonna have the ship, I'm gonna move to the left and the ship is gonna go to the right of us. And suddenly the sound is coming out of a different speaker. That doesn't sound right, does it? So we also need, in addition to setting the listener position, we also need to set the audio listener orientation. And so this is going to be very much like the camera's orientation. So we have the look at vector of the camera, and we also have the up vector, and that orients the camera in space. We're going to have something very similar for the audio listener, but instead of having a to and a from and an up, we're just going to have a forward and an up vector.
Hey.
Forward is going to be x2 minus x from. For y, it's going to be y2 minus y from. For z, it's going to be z2 minus z from. And our up vector, for the camera, that's going to be 0, 0, 1. And I'm pretty sure this is just another one of those GameMaker things. For GameMaker's audio listeners are default oriented upside down. It's a little bit silly. If you go into the manual for the page on audio listener orientation, you can find perhaps what is the funniest image in the entire GameMaker manual, in this disembodied head that's just upside down in a coordinate grid. It's like that so the like positive y and negative y are aligned with the default coordinate system of GameMaker's default 2D camera, but it is fairly funny, and I do believe if you want to set the listener's orientation in 3D, you're going to want to set the z up to -1. Sometimes you run into similar issues like that in the 3D camera system as well, but for here we're gonna do it for sound. So now, if I stand in front of the ship, all right, that is coming out of, I would say the right speaker, but it's not coming out of the right speaker. It's coming out of the left speaker. So I guess I should say the correct speaker. And this is also going to be true no matter where we are relative to the ship. If I move left or right this way, or if I am walking away from it in some direction. All right. I can see the audio levels dancing in their little colored bars in my recording software, so I can see that it's working. So that's audio listener orientation or position and orientation. And if all you want is a couple simple sound effects and you're not working with emitters, that should be all you need. However, if you are working with emitters, this gets a little bit more interesting. So if you want to play sounds on audio emitters, and if you want to have audio emitters have a specific position in the room, we can do all this with audio emitters. So I'm going to create an emitter. I'm going to call it Merry Emitter. It's going to be audio emitter create. We're going to need to set the position of the emitter, so that's going to be audio emitter position. Let's comment out this original sound, by the way. We're going to need to give it an emitter ID. That's going to be the Merry Emitter. We're going to need to give it a 3D position. And I'm actually going to, let's say Merry X is 250. I'm going to save these to variables, instance variables, for something that I'm going to do in a minute, instead of hard coding it. So the X, Y, and Z coordinate, that's going to be our emitter position. We're going to need to set the audio emitter falloff, and that is going to be the these three arguments in the audio play sound at function. So the falloff reference and the maximum distance and the falloff factor. We can take the Merry emitter. We can take our reference distance of what did I give it, 200, and our maximum distance of 2000, and our falloff factor of 1. It's probably worth, by the way, playing around with these values to figure out like what works for your game. These are going to be values which the ideal values are going to be different from game to game. And lastly, audio emitter. Now it's audio play sound on. The emitter ID is going to be the Merry Emitter. And the sound ID is going to be that. That's a long name. Loops is going to be true. Priority is 100. And now, we're going to be doing the same thing as we were before, but with an audio emitter. Alright, you hear it changing as I walk around it. Alright, good fun. And also if I like turn in place without actually moving, you can hear it moving from left to right. So this allows you to do some additional fun things. So if, let me go to the draw event and where I'm actually drawing the pirate ship, which is going to be here. Let's actually draw the Going Merry at that position instead of hard coding its position. I can also say, if you want, for example, the pirate ship to move forward, Merry X plus equals 1, Merry X plus plus, or plus equals 10, or however fast you want it to move. And if we also update the position of the audio emitter as the visible object moves, then we will be able to hear the sound actually moving through space. So if I run the game now, if I stand somewhere in front of the pirate ship, it's going alright. It's going merry. And you can hear it fading as the ship proceeds into the distance. And that is something that you can only do with moving emitters. You can only do that with setting the emitter position like this. You can't really do that with audio play sound at the simple way, because sounds like that are very fire and forget. So if you want to have a sound that moves through space as it plays, then you're going to need to use audio emitters for that. And also, honestly, audio emitters are good for so many other things that you probably should be using them anyway, instead of just the regular vanilla play sound functions, but that's neither here nor there. So there's one more thing that you can do with positional audio that's quite cool, and that is going to be the Doppler effect. So pitch shifting sound effects as they are moving through space, if they're moving towards you or away from you. This is something that is often explained in real life in terms of, like, if you hear a police siren or an ambulance or some other loud emergency vehicle that's coming towards you at a high speed, it's going to be pitched upwards because as the source of the sound moves through the air towards you, the sound waves get compressed, and that results in a higher pitched sound. And as it moves away from you, the opposite will happen. The emitter is moving away from you, the sound waves get stretched out as they're emitted, and longer frequencies, longer wavelengths of sound are going to be interpreted as a lower pitch. And to be honest, Doppler shift is quite cool because you don't actually have to be moving at that high of a speed in order to observe the effect. I don't want to get super into how the change in pitch for a Doppler shift is calculated, because that's not really very important for us right now, but it's a fairly simple equation. It's right here on the screen. But if you use an online calculator like this one, which I guess I'll link in the video description, and let's say you have the frequency of a sound is middle C, and let's say that your receiver velocity is 0, and let's say your source velocity is moving like 10 miles an hour towards you, then you can actually see that the frequency of the sound that you'll observe is going to be pitched up. That's a little more than 1%, which is a decent run speed for a human and more than enough to be observed by ear. And in fact, I shot some video of me going out and riding my bike and playing music, and you can actually hear the change in pitch as the source of the sound passes the camera. Anyway, what were we talking about? Positional audio. So if you want to feature some Doppler shift in your games, and I can't honestly think of many games where this is really a thing. I know that in Mario Kart, if you hear someone coming up behind you, they'll be pitch shifted up, and if they're receding, they'll be pitch shifted down. But we have a function audio emitter velocity, and we can plug the merry emitter into that. And our the going merry's velocity in the x direction is going to be 1, 0, 0. You also have the audio emitter, or audio rather listener velocity, if you want to set the velocity of the listener instead of the emitter. But I don't think I'm going to do that. Not here. I'm just going to be playing with the velocity of the audio emitter. If you want to set the velocity of the listener, you probably want to do so here, where you're dealing with the rest of the listener parameters. Future Michael jumping in here. I somehow forgot to mention this in the original recording, but I'm 95% sure the units on the emitter and listener velocities are to be defined in meters per second. This is based on experimentation. I was not able to find any official confirmation of this. It feels like something that should be written down in the manual, but as of my speaking, it isn't. But based on how the pitch changed when I played around with different numbers, I'm pretty sure it's in meters per second. It's important to get your units right when it comes to sound, regardless of what the units in your game world are. If inside your game, one GameMaker unit is equal to 1 meter, then you're mostly fine. You just have to make sure that that's expressed in distance per second instead of distance per step. If you're like me and you usually work in 32 GameMaker units equals 1 meter, then you're going to have to do some conversion there. That's all. Back to the video. If I just run this, we're not really going to hear much of a change. So let me stand in front of you. And you can't really hear much of a change, but if you set this to something higher, like 10, then we should be able to hear the Doppler effect. We should be able to hear the ship pitch shifted up as it approaches us. And then it's going to drop off as it moves away. By the way, I really, really wanted to use the One Piece beer song, Thanks to the Sake, for this demo, but the anime industry tends to be a little bit touchy when it comes to people using their music. Like, I don't really care about the demonetization or whatever for the sake of a joke like that, but I did not want to risk them, like, blocking this video in 50 different countries just for the sake of a joke like that. So instead we'll just be we'll be using the music that I do actually have permission to use. Alright. So that's fun. There's a lot of cool things you can do with 3D audio in games in general. As much as I might sometimes complain about doing it badly and it giving me a headache, but really there are some cool things you can do here. By the way, if your game is using 3D audio like this and you have some sounds that you specifically don't want to play in 3D space, such as actual background music you generally don't want to play in 3D space, or as I said before, like UI sound effects, you can do things like playing those through an emitter that is always set to the listener's position so that it doesn't attenuate and it doesn't pan left or right. To get rid of panning specifically, like I mentioned, what was it? You can set the output type to stereo, and stereo sounds shouldn't pan left or right. That feels like a bit of a hacky solution. I'm not actually sure if there is like a proper way of preventing some sounds from behaving like positionally. Setting the emitter for background music to the position of the camera should be fine. As far as I'm aware, the audio falloff model is a global setting. You can't set that per emitter. Yeah, there's no emitter falloff models. If there's any better solutions to doing that sort of thing, feel free to shout them out in the comments, because I feel like there should be a better one than just setting the background music listener position to the position of the camera. Anyway, I'm going to end it off here. My name is Michael. I like Wizards and Dragons and making games. If you want the code for this, look for the GitHub repository down in the video description. I try to post about 2 game dev videos a week, one tutorial like this, and one Let's Make a Game. Currently a 3D wizard game, so if any of that appeals to you, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. And for God's sake, remember to wear a helmet when you go out riding your bicycle. Special thanks to Zenjamin, Vitro V, Squarecrow, Sindra Larson, Manta Ray, GameMaker, Edward Holt, DJ Gibbles, and Army Armbuster for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.